Dear students, next example in Bode plot. Sketch the Bode plot for a unit feedback control system with forward path transfer function g of s is equal to 24 by s plus 2 into s plus 6. Determine the gain margin and phase margin. So for this, initially we can draw the Bode plot for 24 by s plus 2 into s plus 6. After that we can calculate the gain margin and phase margin, gain crossover frequency and phase crossover frequency. So initially we can draw the Bode plot for 24 by s plus 2 into s plus 6. So already we know we want to draw the Bode plot for 24 by s plus 2 into s plus 6. This can be split into the three parts. 24 into 1 by s plus 2 into 1 by s plus 6. So that the given function g of s into h of s is equal to, so here unit feedback system, so that h of s value is 1, so that g of s multiplied with 1 is nothing but same function, so that g of s into h of s is equal to 24 by s plus 2 into s plus 6. Now this can be splitted into the time factor. So why? Because this is simple pole other than origin, so that it can be represented in 1 by 1 plus ts format, so that the time constant form g of s into h of s is equal to, so from this we can take 2 as common, from this we can take 6 as common, so 6 into 2 12, 24 divided by 12 is nothing but 2, therefore 2 by 1 plus s by 2 into 1 plus s by 6. So now it is in time constant format, so that this function can be split into 2 into 1 by 1 plus s by 2 into 1 by 1 plus s by 6. So now the magnitude plot for k is equal to 2. So for k is equal to 2, so 20 log k formula, that is equal to 20 log 2, that is equal to 6 dB. So due to the k constant, k is equal to 2 constant, it will be produces 6 dB constant gain. So the magnitude plot is parallel to the log x, log omega xx at 6 dB line. So this is the magnitude plot for k is equal to 2 constant. Now the magnitude plot for simple pole 1 by 1 plus s by 2. So this is pole other than origin, this is nothing but factor 3. So for factor 3, initially we can calculate the corner frequencies. So then only we can draw the magnitude plot, so that the corner frequency formula. So from this example, so T1 here, the T1 is equal to 1 by 2. The corner frequency formula, so omega C1 is equal to 1 by T1. So the basic formula omega C is equal to 1 by T. Here 2 poles will be there, so that omega C1 is equal to 1 by T1, that is equal to 2. So this is the first corner frequency. So therefore the magnitude plot for this pole is up to omega is equal to 2, that means 2 up to the frequency 2. The magnitude plot is 0 dB constant. After the frequency 2, the magnitude plot decreases 20 dB for decay. So the magnitude plot is a straight line of slope minus 20 dB for decay after omega C1 is equal to 2. Up to this corner frequency 0 dB constant. After this corner frequency minus 20 dB decay, decreasing for decay. So that for decay it will be decreasing 20 dB. So now the pole 3, 1 by 1 plus s by 6. So this can be represented in time constant format, 1 by 1 plus t2 into s, where t2 is equal to 1 by 6. Therefore the second corner frequency omega c2 is equal to 1 by t2, that is equal to 6. So here 2 poles will be there, so that 2 corner frequencies will be there. If 3 poles are there, 3 corner frequencies. If single pole is there, only single corner frequency is there. So that the number of corner frequencies is equal to number of poles other than origin plus number of zeros other than origin. Here only 2 poles other than origin, so that 2 corner frequencies will be there. So this is the magnitudes, individual magnitude plots. Now combining all these 3 magnitude plots, so this is resultant magnitude plot up to the first corner frequency. So this is magnitude plot is a straight line of slope minus 20 dB for decay after omega C2 is equal to 6. So different frequencies up to the first kernel frequency. The first kernel frequency is 2, so that 0 less than omega c1, that is equal to 2. Omega c1 value is 2, so resultant slope is 0 dB. So from 2 to 6, so from 2 to 6, so this is the first kernel frequency, this is the second kernel frequency. So in between these two, minus 20 dB for decay will be decreasing. After the second kernel frequency, minus 20 dB decay for decreasing due to the first kernel frequency, and minus 20 dB for decay due to the second kernel frequency. Combining these two, that is total minus 40 dB for decay. So this is the final magnitude plot for 20 by s plus 2 into s plus 6. So now phase angle plot. So this is the formula, this is the format for calculating the phase angle, that is equal to 2 by 1 plus j omega by 2 into 1 plus j omega by 6. So now design the table, different omega values, corresponding angles. Due to this pole, minus tan inverse of omega by 2, due to this pole, minus tan inverse of omega by 6. Due to the constant 2, it will produces so 0 degrees phase angle. Why? Because k value is 2. If k value is greater than 0, it will be produces the phase angle of 0 degrees. So that here that is not included, because 0 degrees is, if you add 0 degrees, there is no difference. So now at different frequencies, the corresponding phase angles. So due to the first pole, this is the phase angles. Due to the second pole, this is the phase angles. Final resultant phase angles are this one. So at omega is equal to 0.2, it will contribute minus 7.62 degrees. At omega is equal to 5, minus 18.79. Omega is equal to 22, sorry, this is 0.5. Here the mistake is there. Omega is equal to 0.5. This is the angle. Omega is equal to 2. This is the angle. Omega is equal to 6. This is the angle, and so on. Omega is equal to 80 degree. It will be reaches to the minus 180 degrees. So this is the magnitude, sorry, phase angles. So finally we can draw the graph. So first one, magnitude plot. So first find out the first kernel and second kernel frequency. First kernel frequency is 2, so that this is the 2. So this is the first kernel frequency. So this is the first kernel frequency, this one. And omega c2 is equal to 6. So this is the second kernel frequency. 6 is the second kernel frequency. This is the first kernel frequency, this is the second kernel frequency. Up to the first kernel frequency, due to the constant k is equal to 2, contributes 6 dB constant magnitude. Due to the first pole, 0 degrees. Due to the second pole, 0 degrees. So that final the resultant graph drawn at 6 dB line constant up to the first kernel frequency. So after the first kernel frequency, due to the second, that is first pole, it will be contributes minus 20 dB for decay. Due to the second pole, 0 degrees, where the second pole contributes minus 20 dB for decay after the second kernel frequency. Now we are crossing only the first kernel frequency, so that in between first kernel frequency and second kernel frequency, the resultant magnitude plot decreasing 20 dB for decay, so that it will be decreasing 20 dB for decay up to the second kernel frequency. After the second kernel frequency, due to the first pole decreasing 20 dB for decay, and due to the second pole reducing again minus 20 dB for decay. So total 40 dB decreasing for decay. For 10 different values, it will be decreasing 40 dB for decay. So that from second kernel frequency, it will be decreasing 40 dB for decay. This is the final magnitude plot for given problem. Next one, phase plot. So at omega is equal to 0.1. So already the table is there. This is the table. Based on this table, for different frequency values, the corresponding different angles are identified in this graph. So omega is equal to 0.1, 1, 10, 100, like that. At omega is equal to infinity, it will be reaches to the minus 180 degrees. So this is 0 degrees, minus 30, minus 60, minus 90, and so on, minus 180. So based on the different frequency values, we can identify the points, and finally adding all these points, we can get the phase plot like this. So magnitude and phase plots are completed. Now we want to calculate the gain margin and phase margin, gain crossover frequency and phase crossover frequency. So first one, gain crossover frequency. Gain crossover frequency is related to the gain, that is nothing but magnitude. So that the magnitude plot where it will be reaches to the 0 dB line. So this is the magnitude plot. It is reaches to the 0 dB line here. So this dotted line. So this dotted frequency is nothing but omega GC, gain crossover frequency. So at gain crossover frequency, the difference between phase margin graph and minus 180 degrees, this difference is nothing but PM. So that is nothing but phase margin. So this difference is nothing but phase margin. So this is minus 90 degrees line. So this is minus 90 degrees line. This is minus 180 degrees line. So that the resultant value is, so PM is equal to 90 degrees. Phase margin is 90 degrees. And gain crossover frequency completed. Now phase crossover frequency. So the phase crossover frequency is nothing but the phase graph reached to minus 180 degrees. So here the phase graph reaches to minus 180 degrees at infinity frequency. So that here the phase margin, phase crossover frequency, so omega PC is equal to infinity. So at infinity, this magnitude plot reaches to the minus 180 degrees. So that omega PC, phase crossover frequency, is infinity. Therefore omega GC is also infinity. So that frequency, the difference between 0 dB line and this magnitude plot is nothing but GM. This is also infinity. So these are the magnitudes and phase graphs and gain crossover frequencies and phase crossover frequencies and gain margin and phase margins. So this is the Bode plot and how can you calculate the magnitudes and phase plots. So you can solve this problem as homework. So draw the Bode plot for the given system. G of s is equal to 100 by s into 1 plus 0.5 into s into 1 plus 0.1 into s, where h of s is equal to 1. So what are the requirements is gain crossover frequency and corresponding phase margin, phase crossover frequency and corresponding gain margin, stability of the closed loop system. So either the given system is stable or unstable or marginally stable. So I will give the solution. So based on this solution, so we can solve this problem. So this is the solution for that problem. So based on these slides, we can solve that problem. So this is the homework problem. So do all people.